Now, we're going to start our next section over these next 2 weeks, which is going to be on surface area and volume. So I want to introduce you to what these are and what different shapes we can classify these as. So hopefully some of this is going to be review for you. We're going to start off today by talking about prisms. Now, prisms are just shapes that have two polygon bases. So if you see the shape, it's got a top base and a bottom base most of the time, or sometimes it'll have a base on the front and a base on the back. But the main thing is that it has two bases. This is as opposed to a pyramid, which we're going to talk about next week, and a pyramid is going to have one base. But a prism is going to have two bases, base on the top and a base on the bottom. So if you think about a container, like a box of cereal, that would be a prism because it's got the base on the bottom and it's got the base on the top. And we name prisms by what their base is. And so here's our base here. It's got a base on the top, base on the bottom. And because this base is a hexagon, it's got 6 sides, we would call it a hexagonal prism. And this is what's called a net. A net is just showing how the two-dimensional shape would have to fold to become the three-dimensional shape. Hopefully you've seen these before. And the sides that are not the bases are called the lateral surfaces. Lateral surfaces. And this is going to be important because we're going to talk about the area of these places that are not the bases, and we're going to call it the lateral area. So when you see lateral area, it's just the area of this part of the shape. And you'll notice that these are rectangles, which is going to happen in any prism. The lateral surfaces are going to be the rectangles. So when we find the area of this, we're going to use the area of a rectangle to do that. All right, so to recap, we name the shape in the prisms by the base, and we have these lateral surfaces are those rectangles that are not the base that make up the rest of the shape. Before I talk about the formulas, let's talk about what the actual terms mean. Remember I talked about perimeter being fencing and area being carpeting. How much carpeting would you need to fill the space versus perimeter, which is fencing. I'm building something around the border of it. How much of the fencing do I need to build around the border of it? Well, my analogies for you for surface area and volume are that surface area is wrapping and volume is filling. Surface area is I want to wrap around the outside of this shape. How much wrapping paper do I need to wrap around the outside of the shape? Or how much material do I need to cover the entire surface? And surface area is an area. It's the amount of area along the outside of the surface. And so it's going to be in units squared, just like any other area is. Volume, on the other hand, volume is filling. And it's going to be in units cubed. The reason I say volume is filling is I want to fill this container or whatever shape we have with, say, water. And I want to know how much water do I need to fill up this entire space. It's the amount of space inside of the shape. Now, let's talk about these formulas. In my surface area, I'm counting up the area along the outside of all these shapes. So let's look at what I have. I have the base, I've got base here. And then I've got another base on top because it's a prism. So I need two bases. That's why the area of the base here is doubled. Then I'm going to add the perimeter of the base times the height. This is perimeter of the base. And the reason I'm going to do perimeter of the base times the height is because these are rectangles. And so the area of a rectangle is base times height. So if I'm trying to add up the areas of all these rectangles, it's going to be base times height here, base times height here in this rectangle, and base times height here in this front rectangle. And what are the bases? They're each of the side lengths of the bottom and top bases of the prism. And that's how we get the formula. It's the top base and the bottom base, and then we're adding up the area of each of these rectangles. That's surface area. Volume is how much space do I want? You could think of this formula as stacking up a bunch of triangles on top of this shape. So we could stack up a whole bunch of triangles from the bottom to the top to figure out how much space this would need. And how many triangles are we going to accumulate up? It's going to be however tall it is. That's the height of all the triangles that we're going to need. So we're going to take the area of that triangle, in this case, of the base, and then accumulate it up all the way up to the top, times the height. Okay, that's where each of these formulas come from. But what you need to know is how to use it and how to plug it in. I just want to tell you that these come from somewhere. Here's our first example. Remember what I said earlier about we have sometimes a top base and a bottom base, and sometimes we have a front base and a back base? This is an example of our base being at the front and the back. So here's our front base. And then here is our back base. We have a side connecting each of the vertices, the corners, together. That's what makes a prism. So the bases here are hexagons, so we're going to call it a hexagonal prism. Now I'm going to skip over some of the details here because I'm not going to make you do one this complicated. And so I'm just going to go ahead and tell you area of the base. Ordinarily we do 1/2 ASN. And we go through that entire process that we were talking about before. If you would like to try that to see if you can do it right, go ahead. But I'll just go ahead and tell you what we would get here. Number of sides is 6. Side length is 4. Those are given. And then we could draw out the triangle and solve it. But I'll go ahead and tell you that the apothem is 2√3. That means area of the base is going to be 1/2 the apothem, which is 2 square root of 3, times the side length, which is 4, times the number of sides, which is 6. And that's going to give us 24 square root of 3. Lateral area is perimeter of the base times your height. Now, perimeter of the base, we just add up all the sides. Well, what are the sides? The sides are 4. So we take 4 plus, well, all the sides are 4. And that's 24. That means the perimeter is 24. And then I want my height. My height is always my distance that connects the bases together. There's a height, there's a height. Distance that connects the bases together. And that distance is 8. So to get my lateral area, that's going to be perimeter times the height, which is 24 times 8, 192. So I suggest doing this separately in this way, especially the area of the base, because you're going to use them whether you're looking at surface area or volume. Here's the good news. We've done the hard part. So now all we need to do to get surface area and volume is to just plug our numbers in that we found up here. It makes the overall formula less intimidating. That means that twice the area of the base, well, the area of the base, we found it up here. So we're going to go ahead and plug it in right there. It's 24 square root of 3. Plus perimeter of the base times the height. Oh, perimeter of the base times the height? We did that up here. And so we can just bring this down here. Perimeter of the base times the height, it's 192. It was the 24 times 8 that we did up here. So let's get that rounded to 2 decimal places. I get 275.14, and it's feet squared because it's a surface area. Surface area is an area, and so it's in units squared, feet squared. Now volume is just area of the base times the height. So that equals, well, area of the base, we know it already. It's 24 square root of 3. We found that earlier. The height, we've also found already. Remember, it's our distance that connects the two bases. That's 8. Rounded to the nearest hundredth, 2 decimal places, 332.56 feet cubed now because it's a volume. I'm going to do one more example here. Again, the bases are in the front and the back. And then we have our distances connecting them, which is going to be our height. And those bases are perfectly drawn triangles. That means this is a triangular prism. Area of the base would just be the area of the triangle, which is 1/2 base times height. Base is perpendicular to the height. Well, here they are, 5 and 12. So 1/2 the base, which is 12, times our height, which is 5. And that comes out to be exactly 30. Lateral area is perimeter of the base times the height. So perimeter, that just means we add up all the sides in the triangle. So we have 12, and we have 5, and we have, we don't have this side, which I'm going to call C for no particular reason that has nothing to do with how we're going to solve the problem. Oh, wait a second. This is a right triangle. We know 2 sides. Then we're going to do Pythagorean theorem. C squared equals 5 squared plus 12 squared. That's the hypotenuse. And so we can solve for it. 5 squared is 25. 12 squared is 144. Hopefully you should be good to go in solving one of these. Square root of both sides. And we get C to be exactly 13. So this is 13. That means when I add up all the sides, I should add up 12 plus 5 plus 13, which is 30. Then my height equals, well, it's our distance that connects the two bases together, which is this distance right here. Here's a distance that connects the triangles. That's going to be 10. So if you want to know how you know what the height of the prism is, look for a length that connects the bases together. So the length that connects these two triangles together is going to be the height. It either connects the front to the back or the bottom to the top, depending on how it's drawn. Perimeter of the base times the height. Perimeter was 30, and our height was 10. And so that's going to be 300. Surface area, there's the formula, and now we can just plug in the things that we know. By figuring out twice the area of the base, well, the area of the base we found was 30. Plus perimeter of the base times the height. Perimeter of the base times the height, we found it up here, it's 300. And that comes out to be exactly 360. We don't need to do any rounding in this problem. Area of the base we know is 30. The height is our distance that connects the two bases together, which is 10. Oh wait, we're not done yet because we didn't put labels in our answers. This is going to be centimeters squared because it's an area. And this is going to be in centimeters cubed for a volume.